Hey guys, welcome back. Today is the ninth day of this Leetcode challenge, and if you have been following along, you would know that every day Leetcode has been uploading one question for this month of April, and it has this 30 days uh, challenge, Leetcode challenge. So today's question is backspace string compare. So let's get started. Uh, we are given two strings s and t, and we have to return if they are equal. Uh, but there is an additional condition that whenever you observe this pound character or hash character, that just means a backspace character. So you cannot directly use any equals comparison uh, directly. So you have to parse the string and remove uh, interpret this hash uh, as a backspace character and then compare the two strings. So if you look at the example, we have S as A, B hash and C. So when you observe the hash, what you would be doing is removing the previous character. So uh, A will be safe, B will be safe, but as soon as you find the pound key, you would be deleting B. So now you are left with only A, and then the last character C will also be added. So our final string out of this S will be AC. And the same way, if you look at this, you'll observe that the final string will be AC. Now, you can look at the other example as well. However, there is this one point I want to point out that if the starting character itself is a pound character, or if your string is an empty string and it has got a pound character, that just means it won't do anything. So it's an empty string and you are just pressing a backspace, which won't do anything. So in this case as well, since the first pound key won't do anything, but the first A will be removed by the third character, which is the pound key. So after parsing these three characters, you will find your string is still empty, and at the end, the result C will be the output of output present represented by T. And the same way for S, A will be deleted by this pound, uh, post which you'll have an empty string. So this pound, the second pound key won't do anything, and your result will contain C. Now since both contain C, so we are supposed to return true. Now if you look at this note, it says the length of the string both S and T is restricted to 200 characters, and they contain only lowercase letters and a pound key. So that is these are the conditions given. Now there is a follow-up question. Can you solve it in big O of n time? So you have to do it in linear time complexity and without using any additional space. Now this is a follow-up. So I'd like to add that this won't be possible in Java. Uh, the doing it in constant space because the strings are immutable, and since we are supposed to parse the string and interpret the new string and then compare the new parse strings if to check whether they are equal or not, so that won't be possible in Java. So the other option is to use a string buffer, but if you look at the string buffers substring method, which will be required, it has a time complexity of big O of n square. So the you cannot use substring as well. So there's that, because so you'll be ideally what you will be doing is using storing your result string in a string buffer, and as and when you find a particular character that is not a pound key, you would be storing it in the string buffer. Now the append operation in string buffer works in amortized time. So you can see that it takes amortized time, meaning it is a constant time big O of one complexity. But once you find the pound key, you are supposed to remove the character from your string buffer, and for which you would be using the substring method, which takes big of n square complexity, as I showed you earlier. So this approach is not possible. So that is the reason you won't be able to handle this condition, doing this in constant time complexity. However, if you look at the C language solution, it is given as character pointers. So you can probably do this in C language. So solve it in constant space. But since we are solving in Java, I would be using some similar approach. So I will be using a character array for my result. Um, uh, so what I'll be doing is interpreting the problem itself directly. So I will be creating a result of S, which will contain the same number of characters that are present in the S, in string S, and I would be creating a result of T, which will also contain the same number of characters that are present in T. And what I'll do is I'll be needing two pointers, one to point to my original string and the other one to point to my character string. So I would be creating two integers I and j, and yeah, and what we'll do is parse through each of the string and fill our respective arrays. So I'll uh, I'll iterate through the first string, which is s, and now if I find that character at index I in S, if that is equal to a pound key, uh, yeah, if that is equal to a hash, in that case I'll have to check whether my j index is greater than 0. So otherwise there is no point in doing a backspace. As long as I don't have any characters, there is no point in doing a backspace. So as long as if j is greater than 0, that means in one of my character array there is at least one character present. So in that case what I'll do is I'll first my j is pointing to the next available space. So what I should be doing is checking the previously available space and making that character as 0. So if you check, there is no null character. So in character default value in Java, if you look at this, you will see that they are storing a Unicode value of 0. So yeah, the default value for character array, you can say that it will be 0. So if I find that there are some characters present, what I should do is first decrement the value, but there is a possibility that yeah, I can just decrement the value, and whatever is the character at j, I'll store 0 at that position. And if I find that my character uh, the else condition outside for this will be when j is 0, in which case we don't have to do anything. J is the first pointer in the array, first position in the array. So if I, so the else block corresponding to this will be reached when the character is not equal to hash key or pound key. So in which case I have to just store whatever character I find uh, in my S string. So whatever character is present at I will be stored, and I'll just increment my j pointer. I have been doing this mistake, char of j. Ideally, it should be result of s. Okay, and yeah, and outside this if else, I would be incrementing my I pointer. Now I'll do something similar for my other array as well. So I'll have to reinitialize I to 0 and j to 0 as well. And yeah, all the s, wherever I'm referring to the s string, I'll convert it to t string, and my result of s will be converted to result of t. And Yeah, yeah, so this looks good. Now what I'll be doing is I'll just return. Uh, so let me create my result string s, which will be just a new string. Now I know since I'm converting this from a character array, so this should not be a problem. So result of s and result string for t, which will also be created from result of t, and I'll just have to compare whether res strs if that equals res strt result string of t. Let's run it and see if this works. Okay, we seem to have made some mistake. Uh, what we should be doing is we should be trimming this result, because we have allocated some extra space here. So when we are converting those, the number of pound keys that we find will be empty strings. So what I believe this will do is while converting, it will store the extra space. So I'll trim it, and then let's just compare if this gives us the right answer. Okay, okay, I did this trim part outside the string. Yeah, so this should work now, hopefully. Yeah, yeah, this worked, and yeah, this block is coming for when I try to submit. Okay, let me submit this and check. Yeah, solution is accepted. So yeah, now the solution is working fine. And if you observe this result, we are taking in extra space for each of the for two strings, but we are iterating through each of the string just once. So it is still happening in in linear time, but we are not able to use to do this in constant space, because the strings are immutable in Java. So yeah, let's see how good our solution was. So we would probably not be doing so well. Yeah, we are in 62.48%. But yeah, with Java, this probably won't be possible. So yeah, thank you. And if you like this video, please give it a thumbs up, and subscribe if you want to be notified about the subsequent videos that I'll be uploading for other problems. Thank you.